Hello folks, my name is Dr. Zachariah Hildenbrand. I'm here with my colleague Dr. Kevin Shug, and we are the Collaborative Laboratories for Environmental Analysis and Remediation at the University of Texas at Arlington. We're coming to you from the Responsible Shale Energy Extraction Conference, which is a very unique event bringing together scientists, concerned citizens, operators, regulators, and technology companies to have an honest series of conversations about environmental stewardship in shale energy.
We'd really like to thank the support of the Cynthia and George Mitchell Foundation and Earth Day Texas for allowing us to put on this event. We believe that this content that we're going to be providing to those who haven't been able to attend is going to help answer and educate a lot of questions surrounding responsible shale energy extraction. So we hope you enjoy the content.
Very much for inviting me here. I appreciate the invitation from UT Arlington and Clear, and I'm delighted to share this information with everybody here today. Today I'll be talking predominantly about the health risks that accrue to people who live in the urban centers and in the midst of dense shale gas development. As we heard today, shale gas is an industrial extraction, is an industrial process, and now that it is coming deeply into cities and very close to homes, people living close by and in dense development have special risks. First, let's look at the risk of blowouts, explosions, and evacuations. Since between 2006 and 2015, there have been 16 blowouts recorded by the Railroad Commission in the Barnett Shale alone. In Fort Worth in 2006, this involved an evacuation of 500 homes for a half-mile radius. And if you look at Arlington in 2015, these are in the midst of cities. 100 homes were evacuated and over a 1/8 mile diameter. We looked at 3 different shales, and the average evacuation zone in these shales was 0.8 miles, a distance where many people live. And the average number of families evacuated at each of these was 49 families evacuated. Range was from 3 to 500 homes evacuated. Let's look at the risk of burns from blowout fires. 500 feet from a well, again, many people live 500 feet from a well. If a well catches fire, you can expect for people who are outdoors, second-degree burns after 30 minutes. For people who live only 350 feet from a well, if the well catches fire, second-degree burns after 22 seconds. How long does it take to evacuate an elementary school? Well, that's hard data to get, but we know that Sandy Hook Elementary School, after the all clear, took 30 minutes to evacuate. And once again, how close do people live to wells? Texas Railroad Commission has a setback distance from well to residence of 200 feet. This is potential serious exposure. Let's go to hazardous air pollutants. Hazardous air pollutants are known to be emitted from oil and gas development sites, including shale extraction sites, and they include the VOCs, the volatile organic compounds that are emitted along with methane. Volatile organic compounds are known to be hazardous air pollutants and are regulated at the federal level. I want to look at some of these a little bit closer. Benzene is a group 1 carcinogen. That means it is an established, no question about it, cause of leukemia and a number of bad blood diseases that threaten human life and kill people. It also causes diseases of the immune system. Toluene causes neurologic disease. Ethylbenzylene causes lung disease and neurologic disease, and xylenes can cause neurologic disease, central nervous system diseases, brain and spinal cord problems, as well as breathing problems. Together, these are known as defects, as Dr. Hildebrand was discussing. Ozone. Ozone is a product of volatile organic compounds plus sunlight, plus nitrogen oxides, which come from engines and equipment. Ozone has been very clearly linked to asthma, emergency room visits, hospitalizations, premature deaths from respiratory diseases. And children and developing fetuses are more vulnerable to all toxic air emissions. Have any of these emissions actually risen to the level of potential human impact? We do have studies that say they have. This was a study by Macaulay, working on behalf of the West Virginia Department of Environmental Protection in May of 2013. He looked at 7 unconventional drilling sites specifically to ask the question, is 625 feet back from a well far enough to protect people from toxic air emissions? And what he found, I abstracted a number of from the number of different things he published, I looked specifically at benzene because of my interest in benzene. And he found that out of 3 of 5 different sites, 5 out of his 15 samples, 1/3 of the samples set up around the perimeter at 625 feet, exceeded 9 parts per billion of benzene. This is the minimum contaminant limit established by the federal government for exposure of 14 days or less. 1/3 of the samples exceeded that in West Virginia. This is a study of benzene in the Denver-Julesburg Basin over the Wattenberg Gas Field. The Wattenberg Gas Field is a huge, dense area of natural gas development. Northeast of Denver, it contains 25,000 wells. And this was surveyed by NASA Discover's airborne mass spectrometer to detect volatile organic compounds and correlated with a ground site in the middle of the gas field. These were 5 airplane spiral flights that monitored where these compounds were coming from. Findings were of unexpectedly high benzene levels found over the gas field, higher than in Denver. Denver should have a lot of cars, is a large area of benzene emissions from vehicle sources, and yet the gas field, which is over a rural area, had higher levels of benzene over it than the city of Denver. Through multiple analyses, they found that these benzene emissions over the gas field were from the gas field and not from vehicles. And they also found that benzene levels were significantly higher at night, having to do with the atmospheric characteristics that kept benzene close to the ground at night. And there were repeated peaks as high as 21 parts per billion. You recall I told you 9 parts per billion was the minimum contaminant limit, the potential toxic limit for 2 weeks or less of exposure. Once again, showing unexpectedly high benzene levels over gas fields. Let's look now at human illness. I'm going to show you 6 high-quality, peer-reviewed studies looking at the specific question, do people get sick who live close to wells? The most recent study was published hot off the press, February 2017, published by Mackenzie and her colleagues at the Colorado School of Health. They were looking at cancer, at childhood cancer. They looked at all children with cancer in rural Colorado from 2001 to 2013, and they were able to identify 87 cases of acute lymphoblastic leukemia, that's the most common childhood cancer, and 50 cases of lymphoma, non-Hodgkin's lymphoma. Many of you in the audience may have had personal experience with leukemia and lymphoma, and everybody knows how bad leukemia is. You will be pleased to know that there is currently an 85% survival rate for children with leukemia. However, that means 15% of them die. Mackenzie and her colleagues correlated these with controls, 528 people who had cancer, but not this type of cancer. So the control population was actually much sicker than the usual control population. So these results may be biased actually against the claim of disease because the control population was already sick. And then they identified all the oil and gas wells that were existing in rural Colorado, and they geocoded, they correlated the location of the residence of the patient with the location of the wells 10 years before, because remember, you're going to be exposed to the toxin for a period of time and then come down with the disease. So these researchers adjusted for the fact of exposure, and they looked also at distance to well, used something called inverse distance weighted wells, distance, and this is a very strong design, and it was case control and even stronger study design. So what I'm telling you is this is a well-done study, excellently published, peer review-wise, good controls, good population. And what they found was that children 5 to 24 with leukemia were 4.3 times more likely to live in the area of highest well density compared to controls. And the risk of leukemia, ALL is acute lymphoblastic leukemia, increased as you got closer and closer to wells. And the results were adjusted for a number of factors that are known to cause leukemia to make sure that it wasn't due to something else. The only thing they couldn't control for was smoking. And no association was found for leukemia in younger children and non-Hodgkin's lymphoma. So the conclusion here is that living close to wells and in the midst of high density oil and gas development increases your risk of children developing leukemia. This is another study, probably our highest quality study to date. It was published in the medical literature in JAMA, Journal of the American Medical Association, by researchers from Johns Hopkins. They were looking at asthma. Remember that volatile organic compounds emitted from oil and gas wells are part of the component of ozone, and there has been a very strong correlation between ozone concentrations in the population and asthma. And so these researchers asked the question, well, are people who live close to oil and gas wells more likely to suffer from asthma? And they did an exceptionally strong study design. They identified 35,000 patients who had asthma and who had asthma attacks, and they compared them to control patients who had asthma who didn't have asthma attacks. And they asked, if you had asthma attacks, did you live closer to a well? So once again, they identified all the wells, geocoded the well location to the residence location, divided well production into 4 different phases, 3 different types of asthma, so you have a grid of 12. And what they found was that asthma patients who were exposed to the highest level of well activity had between 1.5 and over 4 times greater risk of having an asthma attack than patients exposed to the lowest level of activity. This was significant for 11 out of 12 measures. Remember, there was a 12 grid, and increased stepwise for increasing exposure in at least half the items. And it was adjusted for all the relevant factors. This is strong evidence, peer-reviewed, well-designed study, appropriately published by reputable researchers, demonstrating a strong correlation of asthma with increased well density exposure. And here is another study done from Johns Hopkins looking at symptoms. It's harder to get symptoms because these people don't wind up in the hospital and have measures of exposure that are in large databases. So they mailed a questionnaire, got over 7,500 people to answer a questionnaire, correlated the residence of the individuals to the location of the gas activity, and their results were that compared to people in the lowest quartile of exposure, people in the highest quartile of well exposure had a significantly greater likelihood of having fatigue, sinus symptoms, and migraine headaches. Once again, this is peer-reviewed, appropriately designed studies. This being a survey study is not as strong as the previous studies which I showed you on asthma and leukemia. Everybody's worst nightmare, birth defects. Birth defects. Remember, I told you that exposure to volatile organic compounds and exposure to any air toxins affects children and developing fetuses worse than adults. This was a big, important study on birth defects done in rural Colorado. Once again, rural Colorado location is chosen instead of city location to eliminate the compounding factors of car emissions, which produce volatile organic compounds. So this is an attempt to exclude other causes of emissions besides oil and gas wells. So they looked at a very large amount of data, all the birth records in rural Colorado over a 14-year period. And they also correlated this data with all the gas wells. And they looked at a huge data set of 124,000 babies that were born. And then they looked at gas well exposures and divided them up into 3 terciles of exposure. If you notice, these people had extraordinarily high exposure. The low-risk group had 1 to 3 wells per mile. Medium was 4 to 124 wells per mile. And the highest exposure group had over 124 wells per mile that they were living with. And as a reference group, they looked at people who had no gas wells within 10 miles of where they lived. And what they found was that if you lived in a low well density area, 1 to 3 wells per mile, your risk of having a baby with serious major heart defects was 10% higher. If you lived in the second tercile of exposure, that's 4 to 124 wells per mile, you had a 20% increased risk that your baby would have what's called critical congenital heart disease. And if you lived in the highest density of well exposure, a 30% increased risk of major congenital heart disease for exposed mothers. These heart diseases are those that require surgery in the first year of life. These are the leading causes of death due to birth defects in babies. Here was another study published in 2015 in Pennsylvania again, looking at birth defects, looking at over 15,000 births and correlating them with 500 wells and estimating exposure. It's a similar study design. What they found was that infants in the highest quartile of exposures, this is 6 wells per mile, not nearly as much as in Colorado, were 34% more likely to have low birth weight, below the 10th percentile. And I have a medical note here. These babies are at increased risk of death during infancy compared to normal weight babies. However, these researchers were unable to find an increase in premature births. However, not long afterwards, there was a study by Casey and her colleagues, again in Pennsylvania, looking at same type of study design, 10,000 babies, exposure to wells over a period of 9 years. And what they found was that babies in the highest quartile of exposure, that's 124 wells over 20 kilometers, had a 40% risk of having premature birth compared to babies in the lowest quartile of well exposure. And this was statistically significant, as all the results I've shown you have been statistically significant, adjusted for multiple risk factors, multiple variables. Now these babies, low premature births, would be expected to have a 3 to 5-fold greater chance of death during infancy than babies who are not premature. So to summarize, I have shown you only peer-reviewed, high-quality, statistically significant, important data. The Macaulay study was a Department of Environmental Protection study and was not peer-reviewed. And we've looked at the health risks of living that have been clearly established of living in the midst of intense oil and natural gas activities. There's exposure to blowouts and explosions, burns from well fires, and exposure to hazardous air pollutants. And I have shown you the studies showing increased risk of illness for people living close by. And those risks are increased childhood leukemia, increase in asthma attacks for people who have asthma, increase in critical congenital heart disease, the type that takes you to Denton Cooley and gets you operated on, and a lifetime of medications and possibly reduced function for the children. An increase in low birth weight, an increase in premature birth, and symptoms of sinus, fatigue, and migraine. These studies show that the human health impacts are significant and important, and these are good peer-reviewed, high-quality studies, and I believe they deserve all of our attention. Thank you.